Okay.
Good afternoon, Jared.
Good afternoon, Prof.
Yes, how are you, my brother? You're doing well, eh?
Prof, nice to see you. I'm really, really happy to be with you today.
Yes, we all are. It's a very interesting presentation all round, you know.
Yeah, I think we probably just therefore have to make some quick adjustments here.
Yeah.
I'm seeing there is technical hitch with one of the panelists.
Yes.
So how we will do it, we will have the IASA school give us their brief, a small presentation,
Okay.
after which we will have Lawrence from Aero-Bildung in Germany, again, a brief presentation, and I will welcome there my brother, Dr. Prosper from our neighboring NIT, and then Professor Samia, you will summarize this page.
Yes, and I have a presentation also that I would like to share on the TUK modalities in terms of how we execute our program. So that is what I'll be talking on today.
Thank you. Edward, if you are ready, could you please start?
Good evening, everyone. Good evening, Jared.
Good evening.
Good evening, Edward.
I hope you are hearing me and you can see me. Hello?
We can see your slide and we can hear you.
Yes, good evening, everyone. My name is Edward Marete, the head of training and maintenance at the East African School of Aviation. First, received the apologies from the director of the school who was supposed to be presenting his on another engagement. Dr. Sarah, give you a but before then, I will give you a brief introduction of what the East African School of Aviation is and a brief history of the school. East African School of Aviation is an ICAO training center of excellence. Actually, we are among the 9 rated platinum training institutions in the group. Our vision is to be the global aviation training center of choice, and our mission statement is to effectively offer quality training that meets the needs of the global aviation industry by optimally leveraging resources. The brief history of the school is that the East African School of Aviation was established to provide training for telegraphic and teleprinter operators in 1954 by the British government. In the 1960s, the mandate of IASA was expanded to cater for engineering technicians and air traffic controllers. By 1963, the operations of the East African School of Aviation were entrusted to ICAO and the East African community. In 1982, the school was built in the present day location on an 87-acre land, 5 kilometers east of the city of Nairobi, and about 5 minutes drive from the Jomo Kenyatta International Airport. All the services of the school are transferred to Embakasi from Wilson by 1985. Up to date, the school remains the training directorate of the Kenya Civil Aviation Authority. The mandate activities of the school include providing competency-based training for the authority and the aviation industry, to provide competency-based training for Africa and Indian Ocean region, that is AFI region, as a KCA, RTCE agreement. The other mandate is to develop and implement standardization of curriculum for aviation professionals programs. The other mandate is to implement training policies and that are relevant to the approved training organization, and to establish and coordinate research and development. Finally, the other mandate is to establish and execute the beneficial partnerships and collaborations with industry and academia and aviation training academies. Some of our partners include our parent organizations, the KCA, IATA, we have Moi University, we have Trainer Plus, we have Kenyan Bureau of Standards, we have Federal Administration, Aviation Administration, we have Incheon Airport Aviation Academy, and we have Singapore Aviation Academy. Our accreditations include, we got accreditation by ISO, that is ISO 9001, 2015. We are accredited by KCA as an approved ATO. We are accredited by ICAO as a Trainer Plus. We are also accredited as an authorized training center by IATA. We are also an approved government safety inspector endorsed center. We are accredited to offer degrees by Moi University and others. Now, the main objective of today's presentation in this symposium is to showcase to the world at large what kind of equipment the East African School of Aviation has embraced in order to enhance aircraft maintenance training. So first, we have the aerodynamics lab, the lab which is necessary to enable the trainees to understand the principles of aerodynamics and explain the principles of flight. What you can see there is a subsonic wind tunnel, and I can assure you it is only at the East African School of Aviation where you find this kind of wind tunnel in this republic. This lab incorporates such equipment as a subsonic wind tunnel, a flight demonstration wind tunnel, an airflow bench, and associated practical training models for each equipment. What you can see there on my screen now is a flight demonstration wind tunnel where we demonstrate stalling of an aircraft. We also have a very well-equipped modern fluid mechanics laboratory in which we are able to impart to our trainees the necessary skills and to understand the responses of fluids to forces exerted on them, and to understand the principles and concept of fluids. In this lab, you will find apparatus like pumps, cavitation apparatus, Reynolds number apparatus, flow orifices, turbines, some bended and curved pipes, so that we can demonstrate the losses of pressure in pipes. We also have an applied thermodynamics lab, the lab that gives the trainees a practical understanding behind the scientific principles of the relationship between heat and work, and how heat energy from various fuels can be converted to mechanical work. What you can see there are some of the parts or component units of our thermodynamics lab, which includes a jet engine model, heat exchangers, a steam plant, compressors, constant pressure and constant volume apparatus, associated experimental models, and others. Next, in our list of labs and workshops, we have the hydraulic systems laboratory, which is a lab equipped to enable the trainees to diagnose faults and snags in aircraft hydraulic systems. In this particular lab, we selected two systems, that is the landing gear and the flap, which is a flight control. This lab also enables the trainees to acquire the practical skills to maintain various hydraulic systems components and subsystems that include pumps, reservoirs, actuators, various valves. In this lab or this equipment, it has the main operative unit, the operative flap unit, the operative landing gear unit, the contamination test unit, the ground power unit, and the assorted hydraulic system components. We also have a very well-equipped power plants workshop in which we have various types of aircrafts, both cutaway, runnable engines, and engines which the students practice on to dismantle, inspect, clean, inspect, and assemble. In this lab, like you can see on the screen, we have a runnable PT6 engine, which the students are able to run and appreciate the various parameters as will be appreciated from a working live engine. We also, you can see that again from the sign, we also have our non-aircraft on which the students work. So like indicated on the screen there, we have runnable gas turbine engine, we have a non-runnable gas turbine engine for assembly and disassembly, we have a runnable piston engine, we have a non-runnable piston engine for assembly and disassembly, we have cutaway gas turbine engine and a cutaway piston engine. We also have a GPU and the associated equipment for each engine. What you are seeing there is now the next lab, which is the material testing lab. This lab enables the runners to identify composition of materials in an alloy, check cracks and flaws in the materials used in aircraft construction. Beneath, we have various inspection methods or units. We have a visual inspection borescope. We have a magnetic particle inspection equipment. We have an X-ray tomography. We have an ultrasonic inspection equipment. We have an end current inspection equipment. And finally, we have our mechanical workshop where the trainees start their life in aviation so that they can acquire the skills in sheet metal, forming, bending, cutting, filing, care of tools, maintenance of tools, welding, and all other kinds of skills an aircraft maintenance technician will be required to have. Some of the equipment we have in this workshop are the machines, the milling machines, the shaping machines, the bench drills, the pillar drills, bench vices, folding and rolling machines, assorted tools. Yes. In summary, equipments and simulators play a crucial role in addressing changes and improvement in the aviation industry by providing hands-on, practical, fascinating, and deeper understanding of complex systems. And by integrating the technologies in terms of equipment we have shown you in our training, the East African School of Aviation,
thank you.
We ensure that our students are well prepared.
Edward, thank you so much. Really, if you don't mind, please just share the presentation. We can share it with the students and our panelists. In the interest of time, I would want us to move on, and I'll be fair also to other panelists, so we'll have to find a way to manage time because we've gone beyond. So next, I'll go straight to Lawrence. I'm taking note of questions, and we will find space to answer those questions. So Lawrence, please go ahead, after which we'll go with Dr. Prosper, and then we'll go next to Engineer.
All right, thank you very much, Tara, for the introduction and the nice words. Yeah, thank you very much.
I don't know, that's only my screen. Edward, could you please just stop presenting? Okay.
For me, just a sec. Why can I not share now? Here we go. Now it's working. I hope you can see my presentation now.
I'm seeing a bit of start. Okay, perfect. Good.
Is it pop up? Great. Thank you. All right. So yeah, thank you very much for the invitation. Thank you very much for giving us the opportunity to speak here today. I'm very honored. Me as a training manager and head of international training projects from Aero Bildungs GmbH would like to give a short, brief presentation about the company. And yeah. We are an aviation training center, a mid-sized company in Germany, based close to Munich. We are family-owned business. And first of all, I would like to give you just a very brief introduction about our capabilities before I start then with one of our training concepts. So first of all, we are an EASA approved Part 147 maintenance training organization. In Germany, we call it LBA approved, which is Luftfahrtbundesamt, which is just our national aviation authority in German. We have customers, all around the globe. We are the successor of the Dornier training department. More or less, we have the approval from EASA, or LBA, however you want to put it, for all the basic major categories. This is A, B1, B2, helicopter, piston categories, and so on. We have the approval for several types. I will show some of them later as well. We are very proud nowadays to also hold the DE-EMA approval for helicopter, military helicopter NH90. EMA or DE-EMA is the European Military Airworthiness Requirements approval. More or less, it's an approach of the European Union or the member states of the European Union to have something like a EASA, so compatible system also for the military, Air Force, military, however you want to put it. This is pretty new, pretty rare, and we're very proud to have that. What we offer is we offer all kinds of trainings, very short-term training, let's say a Part 145 refresher training for human factors, but also we offer very long-term trainings, which I also want to highlight later on a little bit longer. For example, apprenticeship classes for companies, surrounding companies here in the area for aircraft production, aircraft maintenance, avionics, mechanics, and all these apprenticeship classes here in Germany also have to follow IHK standards, which are the Chamber of Industry and Commerce standards, in addition to the EASA standards. What we also do is we do something like a bachelor professional program. I'm not exactly sure how to translate it into English. It's not an engineering degree, it's something in between. Mechanic, technician, engineer, something in between, but it's also something what we offer. And of course, as mentioned before, for more than 10 years, we are in partnership with Aerotechnics Limited Kenya to do EASA Part 66 short courses together. One of our big international project scope is that we do a lot of consultancy and support for Part 147 training schools setups worldwide. And there we have examples. For example, we have 3 schools we supported and consulted in Malaysia for the EASA 147 approval. We have 2 schools currently in Thailand. We have 1 in Iceland, and we had 1 in Turkey, which we consulted and supported to setting up the EASA Part 147 training school. So the most important thing, what I want to show you today is how does, for example, a long-term training concept look like at our school is. First of all, you can see here our wonderful building. It's our own building. In there we have the classrooms. One simple example you can see on the right lower part. It's a standard classroom. We have capacity between classrooms between 10 to 28. We have approximately 25 of these classrooms. These long-term projects or long-term training programs, what I mentioned before, they're always in cooperation with some other companies, and the duration depends on their requirements, between 12 and 23 months. The theoretical part usually for these kind of projects is approximately 30 to 50%. Keep it easy, let's put it around 40%. If we have only 40% of the time, we have the theory part. So what are we doing the rest of the time? Definitely we do practical, which is for us a very, very important thing. Hands-on skills, learning how to treat material, learning how to treat the aircraft. So that means students in the second phase or in a parallel phase have to go to the basic workshops, which you can see here. We have one huge sheet metal workshop with a capacity of up to 100 students. We have our cables and connector workshop. You can see a picture here on the right on top with a capacity of 22 students. This basic practical training usually is approximately 25% of the education from the students or the training from the students. After gaining some knowledge and theoretical knowledge, after gaining some first hands-on skills, usually they are really fresh students, they continue here, do some composite training. Same, composite is getting more and more important for the aviation. And we also have here about 22, we can accommodate at the same time about 22 students. This is also still part of the basic workshop training. After that, they continue or can continue, depends, with the engine shop. We have here turboshaft, we have turbojet, we have piston engines and all kind of these engines where you can learn and get the hands on real aircraft parts. Approximately 10% is usually spent there because, as all the aviation professionals know, a B1 or A1 is not really allowed to do so much on an engine any longer. Yeah, this is usually done by the manufacturer. At the last stage, and a very, very important stage, you will go up to one of our training hangars, one of our two training hangars. On the left side, you see one of the training hangar. On the right side, you see the helicopter training hangar, which is currently ongoing some changes. That's why it looks so empty. We are just moving all the helicopters over there. So that's why it's not yet full over there. But what we have is we have a more or less fully functional Dornier 3-8 or Dornier 2-8 for the practical training. We have two Alpha jets over there. We have a piston aircraft there. And of course, we have some helicopters, which is in our case are the BQ-117s. And also we have one CH-47 military helicopter, big one, and one mock-up for the CH-47, because we're in partnership there with Boeing to deliver the training for the German Air Force. And at last, I want to share a picture of our EASA examination room. We have capacity of 28 students at the same time there. They can do it here on computers, or they do it on the paper. Both is possible. Always depends on the practicability, but everything is possible. More or less that's it. Very fast, very rough, but I hope I could give you some insights how our training facility and such a training facility can look like and looks like. And I think, Charlotte, if you have any questions or anybody has a question here, you just forward it to me later on, and I'm happy to answer it. And I hope I'm in time. Let's see. Thank you very much.
I will share. It's basically about the EASA license program program, and we will have those shared and answered with and feedback sent to the students. Ladies and gentlemen, I want now to welcome Dr. Prosper Mugaya from the National Institute of Transport in Dar es Salaam. Dr. please, karibu.
Asante. I think you can see my presentation.
Lawrence, you have to. Okay, thank you. Now, Dr. your presentation should be coming up. Yes,
okay,
we can see
okay?
it. It's fine.
Thank you. Welcome. Thank you, Gerard, for organizing this very good meeting. I will just give an overview. This is National Institute of Transport, and the one speaking to you is Dr. Prosper Mugaya, who is the rector of the National Institute of Transport, which basically is a public institution and is mandated to conduct training, do research, and consultants in all 5 modes of transport, including the aviation. Now, for this particular session, I will share much on the aviation part of the training that we are conducting. And the institution was established in 1982. That is, I think, is just a brief for establishment, but I will go direct to the NIT capacity in aviation. As I've just mentioned, the aviation training at NIT started not very long ago, is in the year 2015, where we have a number of programs that we are providing. We have aircraft maintenance engineering at bachelor level and a diploma. And when we call about bachelor level and diploma, we are accredited by the National Council for Technical and Vocational Education and Training. That is for long programs. But when it comes to the professionalism, we are accredited by TCAA, Tanzania Civil Aviation Authority. As you are aware that the aviation training, it has to be internationally regulated and therefore recognized. Also, we do the cabin crew courses. We do flight operation courses, which are accredited by TCAA, and the pilot training that we have not yet started, but we have almost there to get accreditation and expecting to start the end of this year. And we also do the professional courses. This is accredited by IATA. Those are the the list of courses, as you can see there, which we are conducting at NIT. We do have staff capacity in terms of instructors, technicians, and the pilots. In this particular case, as you can see the numbers, we have a total of 36. In this particular regard, these instructors are professionals and academicians in the sense that they have to satisfy the NACTIVATE or the National Council for Technical Education in the ladder of academia, but also they have to satisfy the TCAA, Tanzania Civil Aviation Authority, when it comes to licensing, which is the requirement for training the aviation professionals. And the slide that you are seeing is the distribution of our staff that with the licensing, and 3 of them completed CPL and the flight instructor rating in South Africa. That is basically for pilot training. And you can see the others which basically who are they have licensing. They went over training in the US and at Ethiopian Aviation Academy to enhance the capacity of our academic staff. And also there are 2 pilots who are still in South Africa undergoing training for building capacity of our pilot training. As I have mentioned, our aviation training has not started very long. We do have the aviation hangar, which basically it is used a facility for hands-on skills. Students, basically our programs for aircraft maintenance engineering, they do the classwork, they do the hands-on, and they have the kind of apprenticeship where they are attached to the airline companies, And the program that we are having, they would go for 2 semesters, and the third semesters, they go for attachment, industrial attachment. And we have been able to create or to establish MOU, understanding of understanding, and a very good relationship with the aviation industry. So as we are able to get placement for our students. And further to that, when they go in that particular arrangement of training, the last year basically is devoted for apprenticeship, where in the entire year they are attached in the industry to enable them to get the hands-on skills. Now, when it comes to the facilities, for the aircraft maintenance, you can see some facilities there. You have the pneumatic and the hydraulic systems. You have also the landing gear system trainers for engine monitoring system, as you can see there. And also we do have the engines that we have an runnable turbo jet engine, which basically is live. It is made to run, so it's like a demonstration. Students can be able to see, and we have some motorized cutaway, as you can see in that particular display. We do have also the landing gear system trainers, which it has all the systems that is required, and we do have also the software, where we use the computers to train the students before they go to the real demonstration of the trainer that you can see there. We do have also a special room that is called Virtual Maintenance Trainer, VMT, where students here now, they have interaction with the instructors. Then the students, they have to diagnose the problem in the computer. And maybe the instructor at one time, they can put some fault in the system, and the student will be able to identify that particular fault and come up with the solution that they will think that particular fault can be able to be fixed. Also, at times they are given some assignment through this virtual maintenance trainer. And this helps much to simulate several scenarios that the aircraft maintenance engineer, they can face on the ground. Now, for the cabin crew, I think it's good that even if we are looking at the maintenance, aircraft maintenance, but we do the cabin crew training course, which also is accredited by TCAA. We are approved training organization for the cabin crew, and those were some facilities that we use during the training. We have the door trainers, we have the float service trainer, and these are available at NIT and they have been installed. Also, as preparation to start a pilot training in this particular year, we have already acquired a simulator, and also 2 simulators we have procured. They are on the way coming. I'm sure by the end of October, we have received them. Those are coming, which are special for Cessna 172. And for the time being, we have already procured those 2 aircrafts, which basically we are going to use them during the start of the pilot training as for PPL, private pilot license. And also we have ordered next year around January, February, we are going also to receive the aircraft, which is the MAT engine, that is also aimed to facilitate the pilot training. We have already also paid everything. I think in February or March, we'll be receiving the aircraft. But as I'm speaking now, we have the Faculty of Aircraft, the Faculty of Aviation and Technology. And of course, based on through the World Bank project, which basically facilitated by the government, at NIT now we are converting this faculty to the Center of Excellence in Aviation. And through that particular project, they have been able to start constructing the Center of Excellence building infrastructure. As you are seeing there are 3 buildings which are connected together. One of the buildings will be the Center of Excellence building. The other one will be high-tech workshop building for the aircraft maintenance engineering, which basically also we have ordered a number of equipment and training equipment which is coming to NIT. And the 3rd building will be special for the mock-up buildings and the wet drills, simulation facility. That now together, it will form what we call the Center of Excellence in Aviation. As I'm speaking now, this facility is under construction, and this is the progress of the construction. We expect at the end of this year, the facility will be ready, and they will be able to install all the facilities and equipment that we have purchased. With that, I think that is an overview of NIT. Thank you very much.
This is really good.
Thank you very much.
Really good insight. I know everybody's looking at the time, and we're going to manage it. I want to straight go on to move to Professor. And Prof, please, if you're ready, just come in. Dr. Please just pull down your presentation, then the professor can come in.
Yes. Okay. Yeah, thank you very much for giving me an opportunity, Jared. Thanks
Prof,
to
just
Maureen
a second.
also,
Prof, just a
you.
second. Dr. Prosper, I can still see your presentation. Maybe you just stop presenting. Okay, Prof, you can be going on as we clear the screen for your presentation.
Yeah, thank you very much, Jared, and thank you, Maureen, for organizing this event.
I can leave the session, then I'll come in.
My name is Engineer Professor Hamir, and I'm the Director of the School of Aerospace and Vehicle Engineering at the Technical University of Kenya. And I really wanted to talk more about what we do as a university in terms of the teaching and learning and also the facilities. So I would like to first bring on board something very, very important before I share my screen, which will be very brief in nature. Today is a very important milestone in aerospace engineering. Remember, aerospace engineering, in aerospace engineering, our core value is safety, and the engineering that encapsulates it or engulfs it. The Polaris Dawn mission was launched today to study the inner Van Allen radiation belt, and the crew was able to, actually, the anticipation is that the crew, which is composed of two senior engineers, one businessman entrepreneur, and one ex-military pilot, to go and study the Van Allen belt, the inner belt, and to reach almost 1,400 kilometers in altitude, which was never reached until 50 years ago with the Apollo mission, and also surpassing the Gemini mission in 1966 with the Gemini 11 mission that reached 1,373 kilometers above the Earth's surface. So it's very important to understand and contextualize aerospace engineering. So let me try to share my screen. So let me get to my screen. Okay, I think my let me go back again and open up my PowerPoint. It has been stagnating for a while. So I'm trying to open my PowerPoint slide, and I'm trying to share my screen.
Prof, as you're doing that, I think Dr. Prosper's presentation is still on the screen. Prosper, if you could just stop presenting, then it will give us a chance to get in. Okay.
Okay.
Good.
So I stop sharing. Okay.
No, so go ahead.
Can
go
you
ahead
see
now.
my PowerPoint now? Yes. Thank you very much. So the first slide is pretty much covered. I will now dive into the School of Aerospace Engineering, the program. So our school actually evolved from a former department of aerospace.
Prof,
and
you are presenting.
engineering.
Just double check the screen you're presenting. We are seeing the page, the symposium page, not a presentation.
Oh, okay. Let me try to stop sharing again. Let me go back to stop sharing. I think I made a mistake, and I've opened up my PowerPoint. I don't know why I should I just say share material or share screen? Because let me try again.
Maybe you could
try.
probably share the window, go to share window, and
Yeah,
then
I can see now. Yeah, that's correct. Yeah, sorry about the technological mishap as always. I believe now you can see my screen.
Not yet, unfortunately. It's still okay. Something has changed now. Okay.
Yes. Yeah. So if you can see, we are on the second page, which shows the SAVE program, the School of Aerospace and Vehicle Engineering, that evolved in or was established in October 2019, which actually stemmed from a department and then cut across the transport conduit of aerospace, as my brother Dr. Prosper had echoed earlier. So we are not only targeting the aeronautical and aircraft engineering, but we are also looking at the transport conduit, which is railways and automotive engineering, offshore and marine, and space systems engineering. So these departments are being capacitated as we speak. But the currently running department is the Department of Aeronautical and Aircraft Engineering. So that is a bit of a synthesis. And then if you look at how the Kenya Polytechnic came across in 1967, then it became a Kenya Polytechnic University College in 2009. And then Hayati Mheshimiwa Kibaki, the late Kibaki, was able to transform it into a university. So we are positioned more between a knowledge-based training at the top tier level of university and a competency-based training at the tier level, at the lower tier level of the university at one end of the spectrum. So I talked about the departments in survey. These are our 4 departments. 3 are functioning. Only one is functioning. The 3 are being capacitated. When I come down to the programs offered, we have a Bachelor of Engineering in Aeronautical Engineering, which is a 5-year program. Remember, there was a discussion today about the output or the throughput of the knowledge-based economy, of which we are a part of. Knowledge-based economy produces the human talent that the industry hires. So the industry serves as the employer, and the university system serves as a manufacturer of the human talent. And that knowledge-based economy trickles into a mineral-based economy and the whole technology that surrounds it. And we must remember that sometimes we look at our programs, when you look at a B.Eng, which is synonymous to a Bachelor of Science, it is more centric on design. So testing of higher cognitive capabilities, more design-based. When you look at a Deep Tech or a B.Tech program, Bachelor of Technology, it concentrates more on the psychomotor skills. That's where now the licensure comes. And if you look at our program, we have actually worked on a program called the B.Eng Tech in Aeronautical Engineering, which is based on the EASA Part 66 modules in terms of acquisition of the AML, aircraft maintenance license. So we have driven it in that direction such that licensure can be ascertained or achieved through that program. And one of the key things of that program is we developed it, and we are just awaiting some administrative clearances at university level before it is approved and launched into the system. So one thing I will severely or vehemently clarify on is what is aerospace engineering? What is aeronautical engineering? Aerospace engineering is an umbrella term to aeronautical. It focuses more on the advanced design or probabilistic physics-based design, where all the disciplines of aeronautics or aerospace engineering, like aerodynamics, structures, propulsion, and flight mechanics and control, which also imbues avionics, are handled at one time, more like a parallel computing, as opposed to the weaknesses in traditional design, which maybe you will start with aerodynamics, then move on to propulsion, then you'll go to structures and flight mechanics and control. A very fragmented approach. And then also the serial nature of the program of traditional design means when A wants to go to D, if one of them breaks the chain, you are as strong as the weakest link in the chain per se. And also the usage of historical data, reliance on historical data as opposed to physics-based or parametric-based design. So aerospace engineering evolved. One cannot say that traditional design is not good or advanced design is better than traditional design. It is the evolution or advanced design evolved from the traditional design, as how Boeing 777 evolved from the Boeing 767 aircraft. So that is and if you look at our program, we call it aeronautical because it covers also what we call, if you look at the 19 annexes of ICAO, standard and recommended practices, and if you focus in on ICAO Annex number 6, which deals with the operation of the aircraft, you can see where the physics of understanding aircraft operations, the aerodrome, and all that it pertains to it, including human factors and all that, all those aspects of the aerodrome and the flight dynamics. So in actuality, if I were to pin it down, if you look at a pilot does three things, a modern pilot: aviate, navigate, and communicate. And that is what our aeronautical engineering program is focused on.
Prof, if you may allow me,
the next
Prof,
slide,
just a second.
we have a virtual simulator.
Prof, just a second. Sorry for interruption.
Boeing 737 and the A320. We could even call it an emulator.
Prof, if you may just allow me a second.
Then I come down to the aircraft engine that we have in our laboratory. Yes.
Yes, Prof. Thank you.
Yes,
Prof,
yes.
Just a second. We are looking at managing this time.
Yes.
We may we run a risk of losing.
Yes, I can hear. Yes.
We run a risk of losing other panelists. I would request if we could have this presentation, then we share it, and you probably just.
I'm just finishing up. Yeah.
Perfect. Thank you, sir. Thank you. Thank you, sir.
Yeah. Let me just finish up, please. Yeah. Let me get to finish up. So we also have a propulsion system laboratory, aerospace system, where we house the CF6 AT-C2A2 aircraft engine that was from the Boeing 767 turbofan engine for training. Then we also use domesticated partnerships with University of Nairobi. You can see a wind tunnel, 40 meters per second. And also the compressible flow experiment. So we tend to diversify our facilities in terms of teaching and training. Then we also have the Venturi meter. So we use the mechanical engineering workshops and laboratories, very sophisticated, at the Technical University of Kenya. And then finally, our cohesion with industry. So you can see us here, this is my gas dynamics and jet propulsion class that is doing a practical at Hawk Aviation to understand how a turboprop works. We also work with Mr. Ben from Avionics Care in terms of capacitating our students in the form of mentorship. So our year 3s, year 4 students, before even getting to industrial attachment. So that's all I had to say regarding my presentation. I wanted to talk about our university and exploring our program in terms of needs, in terms of industry needs. Our students are the most sought out. That will be the last conclusion in industry. They serve in various places at the National Airline KQ and various places at the Wilson Airport, KCAA, and so forth. So as a university, as a school, we have graduated 9 cohorts already. So this is quite an achievement, and we look forward to collaboration and further engagement such that we can attain the sky and above it. Thank you very much.